Hello everyone. Today I am going to teach you about verification of De Morgan's theorems practicals. The aim of this practical is to verify De Morgan's law using ICs. De Morgan's law, first law and second laws are here. A plus B bar equal to A bar dot B bar. A dot B bar is equal to A bar plus B bar. First law says like this: the complement of sum of two variables is equal to the product of their individual complements. Sum of A plus B complement equal to complement of A dot complement of B. For this, let us see the basic logic gates. Number 1, AND gate. 2 input AND gate, 1 output, input AB, output A dot B. Symbol for AND is something like D. Next basic logic gate is OR gate. 2 input OR gate, output 1. AB input, output A plus B. OR gate, symbol for OR gate is like this. Next basic gate, NOT gate. 1 input, 1 output. Input A, output A bar. Complement of the input. The NOT gate is otherwise called as NOR gate. So, AND, OR, NOR are basic logic gates. Here there are some other logic gates. They are generated logic gates from these basic logic gates. NAND gate is AND plus 1 NOT. One AND gate combined with the NOT gate. Together it is called as NAND. So the output is A dot B bar. Similarly for NOR gate, OR plus NOT. Output is A plus B bar. In this practical, we are going to use AND gate, OR gate, NOT gate, NAND gate and NOR gate. Let us see De Morgan's first theorem circuit. Left hand side of this theorem circuit is one NOR gate. One OR plus one NOT gives A plus B bar. Left hand side. 2 input AB, output must be A plus B bar. For right hand side, one NOT gate, A to A bar, another NOT gate, B to B bar. So this A bar and B bar acts as input for one AND gate, giving output A bar dot B bar. So these are the circuits for left hand side and right hand side. So the truth table will be like this: input AB, combination of logical inputs 0 0, 0 1, 1 0, 1 1. Left hand side output A plus B bar, right hand side output A bar dot B bar. So the left hand side is simply a NOR gate. Left hand side circuit, right hand side circuit. After completing or observing our practicals, we will get the output as 1 0 0 0 for left hand side and 1 0 0 0 for right hand side. First two columns are input, last two columns are output. These three columns we can write for our convenience. Next, Demorgan's second theorem. Left hand side of Demorgan's second theorem is NAND gate. Input AB, output A dot B bar. Right hand side, input AB, output A bar plus B bar. Left hand side, one NAND gate. Right hand side, two NOT gate and one OR gate. A passes through an inverter, comes as A bar. B again through a NOT gate, output as B bar. This A bar and B bar forms input for this OR gate, and the output is A bar plus B bar. The complement of the product of two variables is equal to sum of their individual components. So truth table for second theorem will be like this: input AB, output A dot B bar for left hand side, A bar plus B bar for right hand side. After finishing the experiment, we have to write result as De Morgan's first and second theorems are verified. Let us see the observed reading for left hand side of De Morgan's law. If the input AB 0 0, output Y is equal to 1 0 1 1 1 0 1 1 1 0 for NAND gate, the completed or the observed filled truth table for De Morgan's second law is input AB 0 0 0 1 1 0 1 1, output 1 1 1 0 for left hand side, that is A dot B bar, A bar plus B bar 1 1 1 0. Just compare and verify. For our convenience, we are writing A bar, B bar, A dot B, etc. Procedure. Verification of De Morgan's first theorem. Connections are made for left hand side as shown using proper ICs. Output is noted and tabulated for all combinations of logical inputs 0 0 0 1 1 0 1 1. Same procedure is repeated for right hand side. From the truth table, it can be shown that A plus B bar is equal to A bar dot B bar. Similarly, for second law, connections are made as shown using appropriate ICs. Output is noted and tabulated. And for all combinations, same procedure is repeated for right hand side. And from the truth table, it can be shown that or verified A dot B bar is equal to A bar plus B bar. Logic 0 means 0 volt. Logic 1 means 5 volt. Positive logic. In this practical, we are going to use ICs. Let us see the pin diagram for various ICs one by one. Number 1, OR gate. Pin diagram for OR gate. The number for OR gate is IC 7432. IC 7432 is a 14-pin IC. 7th pin is for ground, is to be grounder. 14th pin is to be connected to plus VCC or 5 volt power supply. Terminals 1 and 2 are input for OR gate, 3 output. 4 5 input for another OR gate, 6 output. 9 10 input, 8 output. 12 13 input, 11 output. In this chip 7432, 4 OR gates are present. By using a single chip, we can use 4 OR gates. Similarly, pin diagram for AND gate, IC number is 7408. Same as that for OR gate, 14 pin, 7th pin ground, 14th pin plus VCC, 1 2 input, 3 output, 4 5 input, 6 output, 9 10 input, 8 output, 12 13 input, 11 output, 4 AND gates. So we call this IC as quad IC. 4 ICs present inside a single chip. Next IC is IC7404 NOT gate. This gate is also a 14-pin IC. Here you are seeing 6 NOT gates. 1 input, 2 output, 3 input, 4 output, 5 input, 6 output, 9 input, 8 output, 11 input, 10 output, 13 input, 12 output. As usual, 7th pin ground, 14th pin plus VCC. Then NAND gate, IC7402. Here also we can see the same pattern as that for AND gate and OR gate. 7th pin ground, 14th pin plus VCC, 1, 2 input, 3 output, 4, 5 input, 6 output, 9, 10 input, 8 output, 12, 13 input, 11 output. The next IC we are going to see is IC7402, that is NOR gate. Here the pattern slightly differs. In all other chips, number 1 access input, here 1 output, 2 and 3 input. 1 output, 2 and 3 input. Similarly, 4 output, 5, 6 input, 10 output, 9, 8 input, 13 output, 12, 11 input. 7th pin ground, 14th pin plus VCC. So, the apparatus record for this practical is IC 7400, 7402, 7404, 08, 7432, one breadboard, power supply, connecting wires, multimeter to measure the output voltage, or an LED which can act as an indicator whether the output is 0 or 1. So this is the circuit for left side of Demorgan's first law. One IC 7402, 2, 3 input, 1 output. So to observe output, what you have to do is take a breadboard, mount IC 7402, connect 7 to ground, 14th pin to plus VCC, then number 2 and 3, through number 2 and 3 we have to go 0, 0, 0, 1, 1, 0, 1, 1, and we have to observe the output through terminal 1 with respect to the ground point. Then measure the outputs one by one. For right hand side, IC 7404, IC 7408. Two chips are required. Mount 2 chip on a breadboard. Connect 7th pin for these 2 chips and 14th pin. Then start connecting further connections. 7404's second terminal should be connected with first terminal of 7408 and fourth terminal of 7404 to second terminal of 7408. 1 and 3 input, 3 again output. Similarly for second law, left hand side, 7400, 7th pin should be grounded, 14th pin plus VCC. Inputs 00, 01, 102 through 1 and 2, output through 3. This is the circuit for right hand side. Same as that for first law. Now let us see how to create circuit. Now I am going to show you how to create a circuit using www.tinkercad.com. Click enter. A page will open like this. For the first time, you have to sign in using your Google account. I have already signed in. So this page automatically opens. Then select circuits. Then create new circuit. The page will open like this. This is the record working area. Here we can select the required components. Some basic components, all Arduino circuit assemblies. Let me click all. Then the first thing we are going to search is breadboard. Search breadboard. This is breadboard regular or normal size, small size, breadboard mini. Click breadboard regular size and let me drag it to the workspace. Okay. We can shift it as per our requirement. The next thing, the next apparatus we need is power supply. For that, we have to search instrument. Click power supply. Drag power supply here. We can also rotate any apparatus as per our requirement. Now I am connecting negative terminal of the power supply to the bottom line. Let me select the wire as black. Okay. Now connect the positive terminal of the battery . Here, since it is positive connection, let me select the wire color as red. Okay. Now the other instrument we need is on multimeter to measure the output. Okay. Multimeter means we can measure voltage, current or resistance. In this circuit we need voltmeter, so I click voltage. Now search IC logic, then select IC 7402. Drag drag and fit it here. Then IC 7402 is a 14 pin IC. The 7th pin is to be grounded, ground connection, therefore black color wire. The 14th pin must be connected to the positive terminal, that is plus VCC, positive connection, therefore I select red color wire. Okay. Then the left hand side of Demorgan's first law. First terminal, second terminal and third terminal of IC 7402 is going to be connected. Number 1 is the output. So the output has to be connected with the positive terminal of the voltmeter. Let me change the output color wire as yellow. Okay. Then negative terminal of the multimeter is to be grounded, black color. Okay. Then take two wire, one from terminal 2 input A and one from terminal 3, that is input B. Now first logic combination is ready. 0 0. Output voltage will be observed using this multimeter. Now our circuit is ready. What we have to do is start stimulation. See, our circuit works. Output is observed as 5 volts. Okay. For 0 0, the output comes as 5 volts. That means logical one. Stop simulation. Let me change this connection B as 1, logic 1. Now our input is 0 1. Let us check the output. Start simulation. For 0 1, we get the output as 0 volt, that is logical 0. Stop simulation. Then next connection, just click on the wire and delete. 2 to 1, 2 to 1 A, delete this wire. 3 to ground, that is 0. Now the combination is 1 0. So for 1 0, start simulation. The output we get is 0 volt. Once again, for 1 0, output is 0. Start stimulation. Then delete this wire. Connect terminal 3 to 1. Now our input A and B is 1 1. Start simulation. The output is 0. So for the left hand side of our left hand side, we get 0 0 1, 1 0 0, 0 1 0 and 1 1 0. So fill the truth. That's all about the left hand side of Demorgan's law. Now let us see the right hand side. For this, the we need two chips. So now we have to delete IC7402. Click and delete. It will disappear. We can also delete these connections. All the other connections may be as it is. So let it be. Now for the right hand side, we have to choose two ICs. Number one, IC7404, which is a NOT gate. Simply click and drag and fit in our breadboard. Then the other IC we need is IC7408. Click and drag. Fit like this. Okay. Let me shift IC74 here. Then if we use two ICs, the first and foremost thing we have to do is we have to connect the seventh pin of the two ICs. Let me select purple. Connect the seventh terminal of the two IC, then ground it. Okay. Similarly, we have to connect the 14th pin of the two ICs together, then connect 14th pin with the positive terminal. Okay. In IC7404 is the NOT gate and IC7408 is the AND gate. In IC7404, terminal 1 input, terminal 2 output, terminal 3 input, terminal 4 output. In IC7408, 1 and 2 are inputs, 3 output. So, we are going to see output through this terminal. Let us change this color as yellow. Okay. Now, the right hand side of the circuit, 1 and 3 of IC7404 is the input. Second pin is connected to the first pin of IC7408. Number 2 to 1. Let me select blue color. Okay. Then number 4 fourth terminal of IC 7404 to second terminal of IC 7408. Let that also blue in color. Now inputs A and B are from terminal 1 and terminal 3 of IC 7404. A connection is over. Start simulation. For 0, 0, we got 1. Stop simulation. For 0, 1, start simulation. Output 0. Stop simulation. For delete this wire. Delete this one also. From 1 to 1. Now input A is 1. From 3 to ground. Now input B is 0. So for 0, 1, let us check the output. Start simulation. Once again we get 0 volt, which means 0, logical 0. Stop simulation. Next case, the combination is 1, 1. So number 1 already connected with positive. Now number 3 to the positive terminal. That is, we are giving 1, 1. Start simulation. Now also the output is observed as 0 volt. So for the right hand side, the truth table will be like this. For 0, 0, 5 volt, 0, 1, 0 volt, 1, 0, 1 volt, then for 1, 1, 0 volt. Now our right hand side is over. Comparing the two truth tables, it is verified that left hand side is equal to right hand side and A plus B bar is equal to A bar dot B bar. So up to this, what we have seen is we have connected Demorgan's first theorem circuit and verify the this truth table. A plus B bar output 1 0 0 0. Similarly, A bar dot B bar 1 0 0. In the very same way, let us create circuit for this second law and we will get the output as 1 1 1 0 1 1 1 0 for A dot B bar, which is equal to A bar plus B bar. So let me show you the guidelines to follow. The first thing you have to search using Google by tinkercad.com. Then in the right top, you have to sign in. Sign in using your Google account. Then in the left side, click circuits. Then click the green color button, create new circuits. The right side, you can see components, search components, select and search components as per your requirement. Then create as per your wish. Check your connections, circuits, whether it is complete or not. Then start simulation. You can observe your output. Have a nice experience. Enjoy learning. Thank you.